Welcome to the Geometry Final Review, Standard 9 Part 3. We just stopped the earlier video. We're running out of time. We needed some time to do problem number 3. There's several approaches to this. I'm going to give the one, of course, that I like the best, and that is to try to use all of our rules that we know to find angles. Okay, first I want to start by putting in what we know. Okay, what we do know from the explanation, they tell us, where is it? That circle P, that AB is a diameter. So I already know that this one, and basically this piece right here, and this piece right here, that those are the same. It tells us that that is 9, and so I know that each of these is 4.5 and 4.5. Okay, we are given the information that angle ACP, this one right here, is 30 degrees. And then we're given that CE is congruent to ED. So that tells me that this one right here and this one right here are congruent. They don't tell us what their measurement is, but they tell us they're the same. Now I do know one little piece of information that tells me. That tells me, remember that if a chord is bisected, that it will be bisected by a radius, then it's going to be a 90-degree angle. That might help us in a moment. I spent a little bit of time when I was trying to do this problem, trying to figure out some of the angles, and I finally came on some good stuff. One of the things I noticed was that we have another radius here. We have this one, but we also have this one right here. So I know that those two are the same. Now this is nice. I now have this, and this the same, so that's also 4.5. But I looked here and I saw this triangle. This triangle right here is an isosceles triangle. Well, I know that isosceles triangles have the same base angles, or the angles across from the congruent sides are also congruent. So this angle right here is 30. I know that this whole shape here is a triangle. So it must be, this angle here has to be, let's see, 60 from 180. This one has to be 120 degrees. And that means that this one right here has to be 60. I already know that one's 90. So I know this one has to be 30 so that we can get 180 in that one. I know that this one is 90 because it's perpendicular. Let's see, which other one did I kind of figure out? Oh, I kind of added a line. I added the line CB. We may or may not use it, but I'm going to add it real quick. The line CB happens, this is isosceles here. Oh, I don't know what that angle is. That's going to stop me for just a moment while I think about this. Oh, this triangle right here, ACB, has a diameter as its side. So I know it has to add up to 90. Well, I've used 30, I've used 60, so I need another 30. So that's a 30. If that's a 30, this is a 60. And if it's a 60, it's also going to be, since these two angles are the same, these two sides are going to be the same. So I've used a little bit of red coloring here. I'm going to color this over again a little bit just so you can see that that one is the same. Okay, so I know a lot of them now. I think that what I can do is take, and I think we're going to draw another triangle. You can see the caps roll into the frame. But I'm going to look, they wanted us to find CE and EB. I'm going to try to find, let's see what I can do here real quick. I'm going to draw this kind of big so I can kind of think about it a little bit. And I know that these two sides are the same, and this is 60, 60, that's 90. And even though I have not drawn a very beautiful drawing, I know that this distance down here is 4.5. These have to be the same, because if I drop a line down here, these angles are the same, it's perpendicular, it's going to bisect. We learned this when we did polygons. So this has to be 2.25, and this one has to be 2.25. Okay, well, I've got a triangle, and I've got at least a couple sides. Oh, these are 4.5 also, because they're radius. These two are radiuses. So I've got enough to find this measurement right here. I need to do 2.25 squared plus the height squared equals 4.5 squared. Now, those are not very pretty numbers, but we found the calculator, so let's see what it says. Okay. 2.25 squared is 5.0625. And 4.5 squared is 20.25. I'm going to subtract this from both sides. And I get h squared has to equal 15.1875. And now's the step where we take the square root of both sides. So I'm going to take the square root of 15.1875. And I'm going to get that h has to equal about 3.89. Okay, now let's look back at our drawing and kind of relate things. Remember that this triangle here was this one here. And so I know that EB, that's this part right here. That one was easy. That's 2.25. And the height, this measurement CE is the height. So CE, and you can't see it because it's off the frame, but it was 3.89 or about 3.89. And so we've got those measures now. Now, I could have gotten to a point, once I knew those angles, I could have used some trigonometry, like figuring out this. I could have said, okay, the sine, let's say opposite over hypotenuse. I could have said the opposite over adjacent. The tangent of 30 equals 4.5 over x, and I could have used that as another means of getting it. There's several ways to do it. There's probably even some other ways of using some properties of circles, but that's the way that I figured out how to do it. I'm going to zoom in for just one moment so you can kind of see a little bit closer some of the parts on it. And okay. Good luck with that section.